hay, straw, grass, wheat, barley, things that animals eat. Josh is making a face at me. Hello, hello, hello. We're going to do some notes on exponents today. So first off, you're going to notice, hey, Miss La Rosa, this paper looks funky. We're going to fold it in half. So that one side we see the exponents. On the inside, we have some more exponents, practice stuff. And on the back, this is where you're going to glue, where it says glue here over and over and over again in various sized fonts. That's where we're going to glue it in on our notebook. So we're starting on the front where it says exponents. So exponents are a way that we represent multiplication. An exponent is used to show that a number is being multiplied by itself a specific number of times. The base is the number being multiplied, and the exponent is the number of times. Oops. Oh wait, no, that was right. Where's it at? This is also called being raised to a power. Being raised to a power. And we'll get into like how we say these different exponents and things like that later. So this first example, 5 to the 4th power. This 5 is my base. That is my number that I'm going to multiply over and over and over and over again. My exponent tells us the number of times. 4, here's my exponent. 5 is my base. 4 is my exponent. What that means, what that looks like mathematically, is 5 times 5 times 5 times 5. I multiply the number 5 4 times. There's no 4 that I'm multiplying. It's the number of times I multiply my base. There's no 4 in my factors. There's no 4 in the numbers that I'm multiplying right now. They have this reminder here that the X means multiplication, but so does that little dot. The dot on the bottom, that's a decimal. But a raised dot, like in the middle of numbers, that also means multiply. So I could also write this as 5 times 5 times 5 times 5 that way. The floating dot also means multiply. There's 3 different forms that you could see this in, and it's important that you know this. It's going to be on your quizzes here in a little bit. The exponential form, that's just like this, where I have my base raised to some exponent. So down here, one of the examples we see is 2 to the 6th power. That's exponential form, 2 with an exponent of 6. If I expand something, what does that mean I'm doing? Expand means you make it bigger. This is an example of expanded form. I'm showing the multiplication that I'm actually doing. So I want to show 2 times itself 6 times. 2 times 2 times 2 times 2 times 2 times 2. 2 6 times. You're going to need to be able to multiply this out for this standard. So if you want to write it on the back side where it says gloomy, if you want to write it in one of the sides somewhere, I'm going to write it on this sticky note to see this example. And what I'm going to do is I'm going to break up these sections to make it a little bit easier on myself. So first I'm going to do 2 times 2, which is 4. Then I can multiply those 2, which is still 4. And then those last 2, which is also 4. So now I have 4 times 4 times 4 that I can simplify even more. What's 4 times 4? 16. Ooh, girl. So now I have 16 times 4 to do. 16 times 4. I'm going to use this area model to help me multiply. If you forgot how to multiply, it's going to be on our notes today, so you'll get to practice that. 4 times 10 is 40. 4 times 6 is 24. I add those up. 40 plus 24 is 64. So in standard notation, 2 to the 6th power would be 64. 64. The next example that they give us is 3 to the 4th power. That's exponential form. If I have an exponent, it's exponential form. The first few letters of exponent are in exponential form. What would that look like expanded? How many times would I multiply 3? 4 times. 3 times 3 times 3 times 3. Then again, I'm going to use some scratch paper to help me solve this, but if you have space on the side or on the back, that's fine. 3 times 3 is 9. So now I've simplified it to 9 times 9. What is 9 times 9? If you don't remember, you can do your chocolate chips and cookie method. Get 9 cookies, put 9 chocolate chips on each, and count up 1, 2, 3, 4, 5, 6, 7, 8, 9. 18. All the way till you get to 81. 9 times 9 is 81. And then the last one, we have 7 to the 3rd power. Try that expanded form on your own. Pause the video quick. Try doing expanded form on your own. You should get 7 times 7 times 7. And again, if I go through and I help simplify it, 7 times 7 is 49, but I still have to do 49 times this extra 7. I'm going to try this the traditional way. 7 times 9 is 63. 7 times 4 is 28. Plus 6 is 34. So we should get 343. 343. If you need to go back, rewind, pause the video to catch up, please be my guest. Otherwise, I'm going to move on to the next page where we're looking at how do we talk about this? How do we say these different mathematical things that we're learning now? So let's open up our pamphlet. We're going to look at the side that says exponents, verbal and special cases. When saying an exponent, use the phrase raised to the ordinal power. The ordinal power. An ordinal number is just the number's exponent. There's another way to say the exponent of 2 or 3. Anything to the second power we say is squared. And anything to the third power is cubed. So down here, if we see n to the second power, And with an exponent of 2, we say that that is squared. If we see n to the third power, we say that that is cubed. We say that that is cubed. And with the exponent of 4 or 5 or 6, there's nothing special there. We only have special words for squared or cubed. So n to the fourth power, the way I would say that is n to the fourth power. N to the fifth exponent, n to the fifth power. And then n to the sixth power, the way I would write that is n with an exponent of 6. If you need to rewind that, pause it, go ahead and do that now. Otherwise, I'm going to move in and talk about special cases. We have a special exponent. If we have an exponent of 1, it's equal to the base. Exponent of 1 is equal to the base. So for example, down here, we have 11 to the first power. That's going to be equal to 11. It's equal to our base. There's only one 11. I'm not multiplying it times anything. I just have one of them. Like it says here again, the exponent of 1 will always be the base. An exponent of 0 means the base divided by itself, and that's where things get ugly. The base divided by itself. So like here, n to the 0 power, that means n divided by n, which is equal to 1. That number divided by itself is equal to 1. So here, down here, oh, we don't have anything. Oh, wait, here we go. Here's 1001 to the 0 power. It's going to be equal to itself. It's going to be equal to 1000, or wait, whoops, just equal to 1. Anything to the 0 power is equal to 1. The one before it, we have an exponent raised to the 0 power. X to the 0 power. It doesn't matter what number x is. It's equal to 1. It's equal to 1. All bases raised to the 0 power, except for 0, will be equal to 1. 0 to the 0 power, we say that's undefined because I can't divide by 0. That's not mathematically possible. So we say that this is undefined. Undefined. Again, if you need to pause the video to write any of that in or see it again, be my guest. Otherwise, let's flip over to the last section, which is you doing some practice problems. So for this top part, I give you numbers in exponential form, and I need you to write them in expanded form and standard form. Let's do the first one together. 9 to the power of 2. How did we say that if it has the exponent of 2? Exponent of 2, we say it's squared. So the way that I would say this is I would say 9 squared. What that looks like mathematically, expanded form is 9 times 9. And what is 9 times 9? 81. 81. I want you to pause the video. Try doing 2 through 5 all on your own. If you need some scratch paper, there's scratch paper in the back by the pencils where we turn papers in all those little drawers. Or if you have some loose leaf paper you can use yourself, that's fine too. But pause the video, try 2 through 5 all on your own. Good luck. If you need help, look at the poster up front. There's some examples there too, to the right of the Promethean board. Okay, 10 to the 5th power. That's 10 times 10 times 10 times 10 times 10. 10 5 times. There's no 5s. I'm not multiplying my exponent. Just that base that many times. That ends up being 100,000. Oh my goodness. We're going to get into some problems later in this unit where we only have tens to exponents because there's some patterns. Next, 4 to the 4th power. That's 4 times 4 times 4 times 4. 4 times 4 is 16. So that means I have to do 16 times 16. 16 times 16. I'm going to do this one the traditional method. 36, 9, 6, 1. 256 here for 4 to the 4th power. 12 squared, that's 12 times 12, which I know off the top of my head. Do you know your multiplication facts? That's 144. And then the last one, 8 cubed, because whenever we have the exponent of 3, remember we say that's cubed. 8 times 8 times 8. Well, I know that 8 times 8 is 64. So now I have to do 64 times this 8. I'm going to break this one up and do the area method for this multiplication. 64, I can write that as 60. And 4. Oh, times 8. 6 times 8 is 48. And then I add my 0 at the end to hold place value for being 60, not 6. And then 8 times 4 is 32. And I add 480 plus 32. I get 512 for 8 cubed. All right. This last one, this one's nice. It at least gives you your exponential form and your answer, so you have a little bit easier chance to get things right. Do process of elimination. Let's do one together. Let's do 6 times 6 times 6 together, and then I'll have you try the rest on your own. 6 times 6 times 6. What would that look like in expanded form or an exponential form? 6 cubed, because I'm multiplying the number 6 3 times. And then I need to do that math. 6 times 6 times 6. Well, I know 6 times 6 is 36. Then I still need to do 36 times 6. 6 times 6 is 36. That's 18, 19, 20, 21. So this would be 216. If you need to pause the video to write that down, feel free, be my guest. Otherwise, go ahead, pause the video. Try 7, 8, 9, and 10 all on your own. Good luck. The next one, I have 2 to the exponent of 1, 2, 3, 4, 5. I'm not even going to solve it yet. I'm going to hold off on it. On 8, I have 5 times 5, or 5 squared. What is 5 times 5? 5 squared. 25. Then I have 3 to the exponent of 1, 2, 3, 4, 5, 6. Oh my goodness. 3 to the 6th power. And then the last one, I have 1 to the exponent of 1, 2, 3, 4, 5, 6, 7. 1 to the 7th power. What's 1 times 1? 1 times 1 is 1. Times 1 is 1. Times 1 is 1 is 1 is 1. So that should be equal to 1. Then next I have 3 to the 6th power or 2 to the 5th power. 2 to the 5th power should be smaller than 3 to the 6th power. So that makes me believe that this is going to be 32. and 3 to the 6th power is 729. You do not get a calculator on this. You need to be able to multiply by hand on your own. So if you have not yet taken the time, please practice those multiplication videos from earlier if this is still a struggle for you. Otherwise, go ahead and move on to the knowledge check. See where you're at with exponents. You can use your notes on that. You can use your notes, just no calculators. Good luck.